In this video, we're going to practice evaluating some trig expressions using what we now know about the unit circle. So what you see in front is just a blank unit circle on the x and y coordinate plane, but I also have all the lines marking the special arc locations. So as you can recall, for example, this location would be that of the arc pi over 6, this would be pi over 4, pi over 3, pi over 2, and so on. You can refer to the full unit circle for all of these special arc length measures. Eventually, of course, pretty soon, those should be memorized. And we're going to use that, not only those values, but then the symmetry we understood also about this unit circle to evaluate basic trig functions. For example, what if I wanted to know what the sine of pi over 6 is? All right, so again, you could put parentheses for the input of pi over 6 or not, but either way, this is the sine of pi over 6. All right, well, let's refer to how this pertains to the unit circle. If I find, first of all, the arc, which is pi over 6 in length, so remember that it start at the point 1, 0, and it would extend to the special place pi over 6, which is the first mark we come to in quadrant 1. If we also happen to know the coordinates of that point, so these were labeled on our full unit circle, and again, with the symmetry, we only have to memorize a few of them, and then we can translate that to all the others. Hopefully you recognize at this point that this x value would be square root of 3 over 2, and the y value would be positive 1/2. So those would be the coordinates of this point, which is the terminal point of this arc, which is pi over 6. So if I want to know the sine of pi over 6, all I have to do is remember that the sine function pertains to which letter? That's right, the y value. So if I go to the y coordinate of this point, I'll find it to be 1/2, which tells me that the sine of pi over 6 is 1/2. Yes, it's that simple, as long as you know the unit circle. Let's do another one for practice. How about the cosine of, let's say, 7 pi over 4. Once we know where that is in the circle, we should be good to go. So first of all, let's recall that 7 pi over 4, that's counting by fourths. To review that, we start here at 1, 0, and count here's the 1/4. This would be 2/4 at the top, 3/4 over here, 4/4, there's our 1, 5/4, 6/4 at the bottom here, and 7/4. All right, so if we know the coordinates of this point, we know the cosine value because the cosine is the x value of this point. So now let's recall all of the symmetry to help us fill in these values. You'll know that the x-coordinate of that point should be the same as the x-coordinate of this point that's directly above it. And if we follow our pattern, remember this is 1 or square root of 4 over 2, square root of 3 over 2, and then square root of 2 over 2 for that x-coordinate. So it must be the same down here, which means this x-coordinate is square root of 2 over 2, and that exactly would be the cosine of 7 pi over 4, square root of 2 over 2. So this trick of using the unit circle and its symmetry works for any value on the circle. Let's look at another example of how we can evaluate trigonometric expressions using what we know with the unit circle. So here you'll see a large, somewhat scary looking expression, and let's see if we can pick it apart using what we know of the unit circle to help. Now, I don't have a full copy of the full unit circle in front of us here, but if you have one, you can feel free to use that until you have it memorized so that you don't have to use it. Let's see if we can do something with this. Now, the first part of this expression is a fraction where the numerator says cosine of pi over 6, and the denominator says sine of pi over 6. Now, if need be, we can redraw the unit circle as many times as necessary just to get a little reference down and know what it is. This is usually very helpful. So let's just draw a basic sketch of the unit circle. It's kind of hard to draw a circle actually, but do your best. And then you'll notice that if you know where pi over 6 is, we know that is, remember, each quadrant has 3 little marks in it. pi over 6 would be the first mark in the first quadrant, and then hopefully you happen to know or starting to memorize all of those coordinates. This coordinate here would be square root of 3 over 2, comma, 1/2. Well, that's all we need to know to evaluate these expressions. So instead of cosine of pi over 6, cosine pertains to the x value of this coordinate, so we'll call that square root of 3 over 2. So that replaces the numerator, cosine of pi over 6. The denominator says sine of pi over 6. Well, we already have that in our coordinate. That would be 1/2, so I'll put that below. Okay, the second part says sine of 0. Okay, well, 0 we know is our initial point here at 1, 0. Those are the coordinates, 1, 0. Therefore, the sine of 0 would be the y-coordinate there, which is 0. And then we want cosine of pi over 2. Pi over 2 is up here at the top. Those coordinates are 0, comma 1. So the cosine would be the x-coordinate there, which is 0. And so once we replace all of our trig expressions with all of their corresponding values from the unit circle, it's just a matter of simplifying the arithmetic here. So root 3 over 2 all over 1/2 would be the same thing algebraically as root 3 over 2 times 2 over 1 if I use the reciprocal of this denominator right here. That we can multiply. The second part is plus 0 times 0. Well, that's of course 0. So let's keep this going. Square root of 3 over 2 times 2, well, those 2's would cancel, giving us square root of 3 over 1, which is of course just square root of 3. So this entire expression that we started with simplifies to square root of 3. And all we did was use what we understand about the unit circle to get all the numbers we needed and substitute them in for each trig expression. This is the way we'll be using the unit circle to evaluate any trig expression, and so there's plenty to practice, as you'll see, and all of them can be done this way. Again, until you are very familiar with the unit circle, feel free to print a copy. You should have access to it, and then keep it near you and reference it as needed. But eventually, such as for tests, you'll not be able to have a pre-printed copy with you. You'll have to redraw as needed, and the more you do that as you're practicing, the quicker you'll get at it.